Are we ready? Can you hear me? Hi, welcome. I'm Bob Costanza, Director of the Institute for Sustainable Solutions. Can't hear us? Better? Closer. Okay, now? I'll start again. I'm Bob Costanza, Director of the Institute for Sustainable Solutions here at Portland State. And we're very pleased to have with us today Dr. Lisa Graumlich. She's now the Dean of the new College of the Environment at the University of Washington. Lisa's had a very long and distinguished career. She started out at the University of Washington, getting her PhD there in forest resources. She was then director for the Institute for the Study of Planet Earth at the University of Arizona. Is that right? Mm-hmm. For a short time, she was the deputy director of Biosphere 2 in Arizona. Quite an interesting place. She might say a few words about that. She then moved on to Montana State. She was director of the Big Sky Institute. She told me these are all places that nobody really knew exactly what they did. So maybe there's a little more clarity in her current position. And after that, she was director of the School of Natural Resources at the University of Arizona before moving to the University of Washington just recently. I guess it was less than a year ago. Last September, or was it?
Last July.
Last July, okay. So about the same time that we moved here to Portland State. So today, Lisa's going to talk about stressors on steroids, climate change, land use change, disturbance regimes, and the future of Western ecosystems. Lisa. Yes. Okay, a couple of quick announcements before I go. Everybody's to turn off their cell phones right now. Hold them up, turn them off, let me see. Good. And when you ask questions, we're asking you to please come to the microphone. This is not so much that we can hear you here in the room, but we're also broadcasting this as a webinar, and so people that are listening over the internet cannot hear you unless you're talking at the microphone. So please do that. Okay, let's join me in welcoming Lisa Graumlich.
And even though my sound guys assured me that my sound would be perfect, is it perfect? You got some good people here. Bob, thank you so much for inviting me here. In this talk, I'm going to talk to you about how climate change, land use change, changing disturbance regimes are fundamentally changing Western ecosystems right now. And I'm going to tell you this thing that's going to seem pretty incredulous. I'm going to say this is all being driven right now by a rise in temperatures here in the West of about 1 degree Celsius over the last 70, 80 years. And, if you can remember your Celsius to Fahrenheit conversion, that's a couple degrees Fahrenheit. And when I tell you that all of this is happening because of 1 degree Celsius change, it can seem kind of incredulous. It seems like, if you go home and talk to your family or your roommates or your parents and you're saying, the climate's changed and it's gone up 1 degree C, it's likely to just kind of not seem like why would anyone be so excited about it. So I'm going to tell you that it's actually pretty profound, and that what this means for us is that as scientists, we are being asked to talk about how we are going to adapt to this. Now, at this point, I need to understand who's in the crowd. Are there any real biologists in the crowd? Okay, so when I say adaptation, you think I'm talking about evolution, but I'm not. I'm not talking about biological evolution where new species are formed. I'm talking about how human communities organize themselves in such a way that they can prepare for or mitigate risks. So I apologize to the biologists because every time I say adaptation, there's always that squirmy feeling like she's really using the word wrong, but we have to sort of enlarge that. How many of you are actually students or faculty members in the sciences? Okay, most of you. And then are there community members here? Oh, good. Okay, so what I'll try to do in doing this talk is kind of talk in such a way that both kinds of audience can understand hopefully what I'm saying, But please stop me if there's something that I'm saying that's less clear. So scientists are being asked to talk about how are we going to get ready for this. And to be frank, it can be pretty daunting. Recently, a group of esteemed scientists got together and talked about how at a planetary scale, we have entered into a time where in any number, in these 9 particular areas, ocean acidification, climate change, biogeochemistry, biodiversity, we have exceeded the kinds of stable variability that we saw during the last 10,000 years in ways that are approaching or have exceeded what is believed to be a threshold by which there will be social and economic consequences. And so when you place it in this context, sort of trying to understand climate change can be quite daunting. And at the University of Washington, my research group, the collaborators, and I are working on this issue in that way in which, what is it they say about trying to eat an elephant sort of one bite at a time? We are interested in trying to understand how to manage the Earth in this time in which human activity is driving the fundamental processes of the Earth system. And we want to do it by focusing on the Western US, Western North America, and in particular for this talk, we're going to be talking a lot about the Pacific Northwest. And there's an amazing opportunity here because anywhere from 30 to 50% of the land in these Western states is public land. It's land that we actually, as citizens, have a mandate to manage. So it's a particular opportunity there. So today what we're going to do is I'm going to talk about science that is emerging. This is stuff that is just in press or just coming out right now that is particularly relevant to understanding the ecological impacts of climate change. I'm going to talk about how is it that we actually detect when some of these processes or drivers are actually exceeding the kind of variability that we know exists in ecosystems. And lastly, I'm here at the invitation of the Institute for Sustainable Solutions, and this is yet another opportunity to interact with Bob Costanza after a couple of decades of doing this. And every time I interact with Bob, he has always said, but Lisa, what are we going to do about this? How do you actually take the science and make it into something that is actionable? So I know in coming here, I've got a context in which just simply giving you a talk in which we kind of say, oh gosh, the sky's falling in and let's go home and have a beer is not enough, and that I want to talk to you a little bit about what solution pathways might look like. Lots of people help me. These are atmospheric scientists, ecologists, wildlife biologists, forest economics, and I'm very, very grateful and enjoy that kind of collaborative work a lot. So at first, I want to talk about how we can anticipate ecologically relevant climate change. And for those of you that study climate change and climate impacts, you're probably going to recognize why I would put that particular butterfly in the upper right-hand corner. That's the Edith checker spot butterfly that a researcher named Camille Parmesan from the University of Texas has studied as a species in exquisite detail. And she has been able to show how populations of this butterfly have been moving both upslope and abandoning habitat downslope, and moving northward, abandoning habitat farther to the south in response to temperature. It's one of those canary in the coal mine kind of species that tells us that ecological populations are starting to shift. Who could have guessed that? Okay, some of you. Now, if anybody can guess why I've got lilac up here, you're really going to get a prize. Why would I care about this exquisitely detailed map of lilac first bloom date? It has changed, but it turns out we know a whole lot about lilacs. And it's this wonderful story that I became intimately familiar with when I was at Montana State University. A Montana State climatologist named Joe Caprio in the 1950s had a problem. His job was to tell wheat farmers in Montana when they should plant wheat. And those of us who have lived for several years in Montana know that it can snow any month of the year in Montana. Like getting the timing of wheat planting in a really short growing season is a really critical question. And he had a fairly good network of weather observers, but Montana's a really big state. And what he realized was that he needed a biological proxy that could tell him when the soil had become warm enough, when growing degree days had accumulated, and could signal that it was time to start planting wheat. And he, turns out, he was biologically quite astute and realized that a particular clone of lilac could be planted all over Montana. And when that lilac had its first bloom, they had the exact phenology that it would, or timing of that biological event, that it would be the right time to plant wheat. Joe did this in Montana. It worked really well. By the 1970s, Joe had convinced weather observers all over the nation to plant this exact same clone, not just the same species, the exact same clone of lilac. And so we actually have a first bloom of lilac data set that Joe kind of just thought would be useful to help people plant crops, plant their flower gardens at the right time. And it's turned out to tell us a whole lot more. So one of the things I'm going to be talking to you about then is this phenomena of phenology, the timing at which significant biological events happen. So in a recent paper, a British scientist put together 400,000 first flowering records from a variety of species all over the British Isles and took that record back to 1753. Statistically astute and critical people notice that when you're back in the 16th and 17th century, you've got really huge error bars on those estimates of the timing of first flowering. But that as you get closer into the 20th century, those error bars shown in gray get smaller and smaller. And that what you see is that since the Little Ice Age, the height of the Little Ice Age, there in the 1800s, the timing of first flowering has moved steadily by anywhere from 2 to 12 degrees earlier in the growing season. It's another one of those figures that you might think, oh my gosh, why would this matter? Well, it turns out growing season timing matters a lot because different species and different parts of ecosystems have evolved to respond in different ways. And the work I'm about to tell you comes from Scott Mills, a wildlife biologist who has studied snowshoe hares and Canadian lynx in the Rocky Mountains of Montana for many, many years. And what he noticed over the last 5 years or so is this kind of strange phenomenon. First, you need to know that the timing, first, actually, going back even farther, snowshoe hares are white in the winter for camouflage in the snow, and then they turn brown in the summer. And the timing of that is based on day length through the hypothalamus. So there is a pretty hardwired timing that has evolved, over hundreds of years, at which time snowshoe hare go from white to brown. As spring has been coming earlier, and snowshoe hares have been nevertheless staying white longer, what Scott observes is, he's walking in the woods, he sees a snowshoe hare, it's all white on brown leaf litter, and it's sitting there very, very quietly because it thinks Scott can't see him because it's camouflaged. And of course, it's not. And so he's actually seen this spike in Canadian lynx populations because the prey, snowshoe hare, has lost its ability to have protective camouflage because of this disaggregation of the timing of snowmelt and the timing of this particular color change. Now, obviously, there's a strong selective pressure here, and this will probably readjust, potentially within decades, but it's the way in which the onset of spring is a fundamental ecosystem driver. Now, let's back up, and I'm going to now call on the work of a couple of colleagues, Julio Betancourt and Greg Peterson from the USGS and Mike Wallace from the Atmospheric Sciences Department at the University of Washington, who bring together some ideas about why the timing of spring onset actually might be not just important for a single ecosystem or a single watershed, but could exhibit this very large scale and very abrupt change in how it changes through time. Okay, there's those lilacs again. It turns out if you don't happen to have lilacs growing sort of in your weather sort of observing area, you can also create a proxy for the timing of that sort of onset of spring that comes from hourly climate data. And once again, people that understand the biology of this have created a very precise definition of spring onset. It's not a sort of casual observance of the first robin or something. There's a very precise way in which is defined as a trade-off between chilling hours and then the accumulation of growing degree days with some ways in which these large-scale sort of warming events are taken into account. And so you can, for weather stations around the West, in this particular study, 265 stations, you can, on an annual basis, define the date of spring onset. And so, sure enough, throughout the West, you're seeing anywhere from a 3 to 4 day trend over the last half of the 20th century in the timing of spring onset. And it has a particular way. I don't have a pointer here. I apologize. This is going to keep the camera guys busy. It has a particularly interesting way in which, if you look at it as a time series, all of a sudden there's this big change in 1985. And if you look at a time series of an atmospheric circulation index called the Pacific North American pattern, and this is something like some of those atmospheric circulation indices you might be more familiar with, like El Nino and La Nina, or perhaps if you're up on this, the Pacific Decadal Oscillation. This is a particular one that an index of synoptic scale circulation that's particularly important for sort of the high latitudes of North America. And you'll see that when the Pacific North American is in a positive phase, we've got high pressure off the west coast of the United States, and that's when we get our warm springs. And it turns out that the Pacific North American Time Series Index and that of this spring index are very, very perfectly correlated, meaning that the spring index is entraining the whole Western North American atmospheric circulation, that it's a function of that. And then if you look at the spring index and that sudden change in 1985, sort of not surprisingly, remember Tony Caprio and the wheat? It turns out it's closely correlated with the date at which wheat heads in a wheat field in the Great Plains, and that has a sudden change in 1985. The center of mass for streams in western United States, what does that mean? That is actually the time, it's a fancy geologic way of saying it's the time in which the greatest floods occur because of the melting of snowpack. So you can think of that as the timing of the biggest floods associated with snowpack melting out. That shows a big jump down in 1985. There's two things that go up: number of fires greater than 1,000 acres and the area burned in the western US. So a seemingly trivial number of days in the timing of spring appears to be setting into motion not just phenology related to crops, but also loss of snowpack and this fire bit. We're going to return to the fire bit in a minute, but what appears to be happening there is as snow melts off faster, fine fuels dry more quickly, so by midsummer, you've got more fuels in a drier state than you would, which is seemingly driving these much larger and more frequent fires in the western US. So in the last several slides, I've concentrated mostly on the last 50 years. And in Bob's brief biography of me, he failed to mention that I'm actually a tree ring scientist by training. I'm one of those people that goes out and cores trees and has looked at how the relative width and the sort of narrow versus wide rings of tree rings reflect climate back in time. And so by nature, anytime somebody tells me something has happened in the last couple of decades, I'm always asking, well, maybe it's part of natural variability. Maybe this is the kind of thing that's been happening for hundreds, if not thousands of years. And how might we tell that? So what I'm going to talk to you about is a paper that's just in press in Science magazine. Greg Peterson, one of my former PhD students from University of Arizona, is the first author. I'm one of a group of about 10 authors that brought together some very large data sets to ask whether this trend we've seen in decline of western snowpack over the whole western North America is since 1950, is that something that is in fact unusual relative to the long-term record? So Greg's project was not for the faint of heart. He had over 1,000 records of April 1st snow water equivalent, SWE. Sometimes the snow people call that SWE. He had, I'm going to make sure I get this right, yes, 66 different tree ring chronologies. And he organized this, first of all, into 3 different watersheds. You see the Colorado River watershed in the lightest blue to the south, the Yellowstone, Missouri headwaters in the medium blue, and the uppermost, northernmost one is the Columbia River headquarters. And then in the Huck 6 subbasins within that, he accumulated the water data as well as the relevant tree ring data, did a series of nested stepwise regressions relating the tree rings and the water, the SWE data during the period of overlap in the 20th century, and then was able to extend that back to 1450 to look at patterns through time. And what you see when you go back in time, and that first panel is 1440 to 1470, is you commonly see what the climatologists refer to as a dipole. If it's wet in the north, it's dry in the south. If it's dry in the north, it's wet in the south. And you see sort of a pattern in which the snowpack accumulation is never, except in one circumstance, reduced for the whole geographic scope of the Columbia through the Colorado. This period from 1565 to 1600, we know from tree ring records, is the worst drought that we see in the last 1,000 years. And it's one that actually goes there from the Canadian border down into Arizona and New Mexico. But by and large, the norm then is to have this wet and dry heterogeneous pattern. Now, in the last 30 years, you've got the observed April record versus the reconstructed April record. One of the things you can see here is just how good the reconstructions are. You'll see perhaps for the Front Range of Colorado, some of our predictability is we're sort of underestimating the drought, meaning that our reconstructions are, in essence, a sort of conservative estimate of drought. And what you see is that this trend in the last 30 years of a drought gripping the Columbia Basin through the Missouri headwaters down to the Colorado is in fact a kind of drought that really is truly unusual relative to the long-term record. Going back to what does that mean? It turns out that loss of snowpack is apparently driving, once again, an unprecedented change in fire regime. In a set of companion papers published in the last several years, Tony Westerling, Tom Swetnam, a couple of fire scientists, have accumulated over 1,000 records of fire in the western U.S. They looked at the fire frequency in the 30 years before 1986 and the fire frequency and spatial patterns in the 30 years since 1986, and they saw a 6-fold change in fire frequency, severity, and size, right again at that inflection point that I described, 1985 to 1986. And in looking, and Tom Swetnam was a colleague of mine at the University of Arizona, and until this paper came out, when Tom would give seminars, it was always a real simple explanation of you got droughts, and then you got fires. If you didn't have droughts, you didn't have fires. And so initially, they assumed that this 6-fold increase in fire must be due to more droughts, more lack of rain during the growing season. That was not an adequate explanation. The best explanation was that you needed a drought plus these higher spring and summer temperatures and early snowmelt, fundamentally changing the fire regime here in the West. So what does this mean? For those of us that live in the West, those of us in particular that like old growth and understand the sort of deep species richness and beauty of older stands, those will become more and more rare. We are looking at moving towards western forests dominated by very, very, very young trees. The forest ecologists in the room know that when we start to think about a landscape that is being burned at much, much greater frequencies than we've seen probably in the last 10,000 years, that we are going to see the ability for non-native species to more easily invade these kinds of species. And we start to then ask ourselves, in this new mode, is that an invasion or is that a kind of restoration? And in the sense that normally we think of allowing natural processes to allow succession to go on in these burned stands, is that really what we want to do? Or is this another case where we need to think of different management options for these large ecosystems? So a very, very fundamentally different West. So how do we manage in the face of this? And the image I have here is, we've been talking, a bit about some of the forests that we might see here in the northern part of the Northern Rockies, but want to make a point that this is, once again, already so visible, particularly in the Southwest. This is a picture shared by Dave Brashears, who studies the pinyon pine wave of mortality that's in the Southwest, where 1 in 6 pinyon pine have died in the last 4 years. A wave of mortality, once again, not like anything that we've seen in the 20th century. So remember, our goal is going to be to try to manage change. And in the Northwest, the public lands are going to be key. And I want to pause and have you think for a minute about the different flavor of public lands. So here's a map of Washington and Oregon. These are statuses that USGS mappers put lands into. And the status 1, if you look up there, what? We've got Olympic National Park, Glacier National Park. We've got some of our Mount Rainier National Park. We've got our sort of prize national park lands. And it says it's permanently protected. Natural disturbances are allowed or simulated. That's some jargon saying if a fire starts in this most protected of land, a natural fire, it will be allowed to burn. So these are our lands that we manage in our most hands-off way. Our status 2 are permanently protected, but that disturbances are suppressed. And so those would be those kinds of areas, recreational areas, where there would not be travel would be restricted, but if in fact a fire occurred, in all likelihood that fire would be fought. Now, if you look at the pie chart, there's a tiny, you can probably almost hardly see it, a tiny slice of the status 1 land. There's a slightly bigger slice of the status 2 land. What we have is a whole lot of this public land. It's permanently protected. It has multiple /extractive / off-highway vehicle use, and it is a big, big chunk of our public resources. And to just break this down a little bit, this is the status 3 land. It's largely Forest Service land, BLM land, a little bit of the state trust land, and it forms the matrix that our most protected lands sit in on the Cordillera, sort of going up the west coast, our western mountains. Okay, Bob, what are we going to do? We need solutions. Well, as a graduate of the UW College of Forest Resources, and that's a college that has been trying to come up with solutions for over 100 years, they are a college that prides themselves about thinking about solutions. I just want to pause and think about what solutions used to look like. So in 1926, there was a very, very large fire. You can see, oh gosh, if the light, can you see Mount Rainier? I feel like it's a cloudy day in Seattle. Can you see Mount Rainier? Okay, Mount Rainier is looming there in all its beauty in the background. And this very, very large fire in 1926 was seen by the public as being not just distressing as a fire, but it so marred this beautiful landscape as you drove up to this treasure of a park, Mount Rainier National Park. And a forward-thinking forester established a demonstration forest. Look at the sign. It says the show window forest. He knew that people were going to be driving up to Mount Rainier, and UW, the College of Forest Resources, could show how you fix things, which was to plant things. And it wasn't just, you didn't just plant. These are some seed trials by different genetic stocks are being planted. And the pack forest was set up as a demonstration forest with the forestry solution of the 1920s that had to do with planting of trees. Actually in the 1920s was a radical concept, that you actually sort of managed forests very, very actively. So that's obviously not the solution that we're looking at right now. And so if we go fast forward into what the solution that we're sort of careening into in this Western ecosystems where they're going to be warmer and earlier springs and much, much more severe fires that are larger in scope and these early successional species. How are we going to manage these, particularly in the context of these status 3 lands? And it's probably going to have to do something with this concept of ecosystem services. Why do we like these forests? Why do we value them? In part for timber, but also for carbon sequestration, also for habitats for wildlife species, in particular some endangered species. And is there a way we can look at the bundle of rights and the way in which these are managed and market mechanisms that might help us to do this? So what I'm going to report on is what UW's pack forest is doing now. And those of you that are associated with state universities know that self-sustaining for a public university right now means like there's no money. So when there's this self-sustaining, as the dean that actually oversees pack forest, I am very, very happy to say that they're doing great. They have some timber sales, they have a conference center, they have some phone tower leases, and they are self-sustaining in a financial way. But Greg Edel, the director of the Center for Sustainable Forestry, realizes that really isn't enough. What is self-sustaining in terms of not having to ask me for state dollars is really not a model of what forestry needs to be like in the 21st century. So with his colleagues Sander Toth and Sergei Rabochava, he has worked on this EcoCell program, which is, can you actually develop a market for ecosystem services that can work in the context of a working forest in such a way that the Forest Service or a small private landowner could actually make decisions that balance economic return and other ecosystem values, in this case, carbon sequestration, and wildlife habitat. These are Greg's slides, so we're going to walk through them, and I hope I do them justice. So we've got a surface here that represents the value of a landscape as a potential way in which harvest could happen, sort of timber harvest on the XY value. This is old growth forest habitat. So as you go from less habitat to more habitat, you actually, in terms of just timber harvest sales, you sort of go down. And in sequestered carbon, as you go from more carbon to less carbon, once again, in that case, the value of the forest for timber sales goes up. And so you can imagine a bundle of rights that have to do with only maximizing timber sales, where you don't want to sequester carbon and you don't care about old growth habitat. Now, alternatively, you could imagine a bundle of rights where you say, let's actually move down that old growth habitat, make a little bit less money, and in that quick little video, you saw a set of harvest patterns where the brown is what's being harvested, the darkest greens are what are being allowed to go into older and older growth classes, where you could just sacrifice a little bit of money and get a little bit more old growth forest. Or you can imagine an even bigger jump, this down here at bundle 31, and you maybe have a little bit more old growth forest, but you also do more carbon sequestration with that particular bundle. Now, I'm going to rotate this over so we can just look at this slope. The upper red is where you make the most money, the purple is where you fall off the financial cliff. And what would an auction look like where you try to, let's take that bundle 31 that was kind of a nice compromise of got a little carbon sequestration, you got a little old growth habitat. What would it take to create the buying of those development rights such that you could reach that maximum timber profit? And that what he is experimenting with is how large numbers of individuals making small contributions can actually create the resources, the financial resources to actually buy the rights to have old growth carbon sequestration as well as habitat. And you could actually imagine then that there could be different combinations of that dial of old growth carbon sequestration and habitat that you might put together. And in fact, they are running an auction. They did a simulation earlier this spring, and are going to run a real auction in which these rights are going to be auctioned off, and it's going to take place over 6 weeks. So let's say that I'm most concerned about carbon sequestration, and I start to put my bids in on carbon sequestration. But I notice that my friends over here that are concerned about wildlife are sort of starting to bid up wildlife, and I realize if I move my bids over to their bids, we're more likely to get over the maximum timber harvest price and have a successful optimization of this. And so it's a way in which not only does the bidding occur as individuals, but people can change their bids. You'll notice that there's ways you can sort of log in, and that you've got the ability to, as a community of small conservation investors, actually create the community consensus on how this land should be managed. And this is not only being sort of done here in Pack Forest, they've got a pilot project in New Zealand, Chile, as well as in the Deschutes National Forest here. So why do this? And I just want to pause as we sort of make some final comments. to think about what's at stake. I just went through an elaborate technical description of how you might actually manage, in the end, a tiny little experimental forest in Western Washington in such a way that conservation and carbon sequestration values could be brought to bear in addition to timber harvest values. We need to come up with those kinds of solutions, not just for our most pristine lands, but for that whole matrix that doesn't just extend from the Canadian border to the southern Oregon border, but this slide is to remind you that this is the Western Cordillera that goes from the Yucatan to Yellowstone to the Yukon, and it is a rich biological reserve unlike almost any other in the temperate US. And if we are going to be able to adapt to climate change and allow species to find their movement up and down that Cordillera in response to climate change, we have got to come up with the will and the mechanisms to manage those public lands in such a way that we as community members actually have the ability to change the course of biodiversity conservation in the West. So, in closing, particularly for those of us in the academy, unless we take the discoveries in our labs, the discoveries of ecological science, and translate them into meaningful actions, into solutions, in the words of Bill Schlesinger, those scientific results will be quietly archived while the biosphere degrades. Thank you for your time.
Thank you, Lisa. Questions, comments?
Yeah, do you want us to go to the microphone?
Yes, please.
So thank you very much. It's nice to know there's no problems. That was a joke, by the way. I just wanted
could
to
you say who you are, by the way?
Oh, I'm Richard Brhon, and I produce and moderate panel discussions with a lot of the world's top climate scientists and have a NASA grant to teach climate change. And I write for the blog Climate Progress also. And we have any people that we work with, and when foresters are seeing a tree die, they often, or when the media reports on something like a forest fire, they don't often seem to put it into context. And I'm wondering how we can help the media and the public understand the context that when a tree dies from pine beetle kill, it might have been experiencing drought that didn't allow it to have the health to fight off the pine beetle kill. And in addition, I wanted to ask you about ozone, tropospheric ground level ozone that creates a cumulative, it's the best word for the cumulative soup of all human pollutants. And I want to ask if you feel that could also be impairing the health of trees and not allowing them to fight off pests and diseases that they otherwise might have been able to fight off.
That's an interesting set of questions that gets at, starts to unpack this very broad overview I gave of climate change and variability at very, very large spatial scales and the degree to which this is in part creating sort of new and novel large-scale patterns of early successional species, because of fire. The tree mortality issue, of course, is complicated by disease vectors and pathogens, as you pointed out. And that's an area in which there's a lot of work going on. The work I'm most familiar with, having moved from Arizona just in the last 9 months, is the work on pinyon pine, where, in part, moving these pinyon trees into Biosphere 2 and subjecting them to drought and very carefully monitoring them, that we know that the susceptibility to the pine beetle comes because of the decline in sort of net carbon production, that we're getting at the mechanisms of that. And there's a whole series of papers around that. For every species, there's going to be multiple pathogens and the biology of a system that we're going to need to understand, and it's going to create differential vulnerability. I'm less knowledgeable about ozone impacts, and certainly know that particularly in certain areas that's clearly going to be another impact as well. But what I was trying to paint in the picture is this very, very large scale way in which increasingly I think we need to think about managing not just single species and sort of single watersheds or single national forests, but how are we going to come up with a coherent management approach that goes from Mexico through the western US up into Canada to talk about managing these very, very large scale changes as we actually see a biological reshuffling in the 21st century.
My name's Wayne Wakeland. I'm a faculty member in system science here. And what struck me is I was curious about what are the motivations of the people who are buying these services to sequester carbon and encourage biological habitat? Do you know how they're motivated? I mean, are they just experimenters right now? I mean, on a large scale, I guess wonder, can we really see, major amounts of resources coming in over maybe people who have really goodwill and are generous and all that? I don't know, is that enough of a question? I'm not sure that...
Well, I think that's part of this experiment, is to actually see what is the size of that market. I have to admit that same question came to me, and as a citizen versus a scientist, what I reflected upon was the amount of investment that has been made, for instance, in land conservation programs like the Trust for Public Land or the Nature Conservancy, dollars that perhaps more so a decade or so ago were put into the actual purchasing of land. And it seems to me that we're talking about the same kind of citizenry that might make those same kinds of investments. Here then, though, once again, in working with creating viable rural communities where the self-interest could be either maintenance of wildlife, for hiking pleasure or something, sort of hedonistic values, I think is what an economist would talk about. It could actually be potentially even more selfish than that. Say I had a lovely home, on a small lot next to one of these Forest Service lands or small private forests. And what I wanted, it may be in my best interest for me to maintain my lovely view, is to not have that converted to more real estate. See, I got my lovely home and nobody else can come, in this scenario. So you also might see people that are trying to, for the aesthetics of a recreational area or a home site, try to maintain this working forest matrix. And your question, I'm now speaking as Lisa Graumlich. I'm not speaking as, someone of great knowledge about what economic drivers we currently have, particularly since I've lived in the Northwest for 9 months, and would welcome any other comments about what might motivate someone to do that.
Is it currently set up so that, sorry about this. I'm really loud though. No,
it's for, you know what? I think my mother is watching in Ohio and she wants to hear your...
Is it currently set up so that institutions that need to purchase carbon credits but can't do so because there's not really a market here in the United States could purchase and could bid on these carbon credits against the companies that are bidding on timber? Because I know that carbon markets internationally are always looking for more opportunities and wish that there was a carbon market in the U.S. because they would be bidding already and buying those credits in America. Is it possible with something like this that they can start putting in bids on small projects like this? I
think that bidding process in which the carbon credits are owned by the company would be different. And this process, it seems to me that the carbon credit is owned by the landowner. But I'm going to get back to you on that. Yes.
Say who you are.
Evan Thomas, I'm faculty in engineering, and we do a lot of work with the carbon markets. And one of the concerns is that the carbon market's not well set up for dealing with forests, because most carbon credits represent a project that lasts for a year or 2 years or at maximum 10 years, whereas to get the carbon benefits out of a forest, you have to never cut down the tree. And so there is a mechanism set up called RED under the United Nations that deals with big swaths of forest, but I was wondering about the time scale on this proposal. When you buy that credit, is that valid for protecting that tree or that set of trees for a year, 10 years, indefinitely?
Because we zoomed through those animations, let's see if we can get them back. Okay, watch carefully. So what you'll see is that this is a long-term harvest plan that is maintaining the carbon as an aggregate over the watershed that Pac Forest is in. So it's not dependent on a given site. Maintaining its carbon is dependent upon the aggregate. And
does the purchase last for the lifetime for indefinitely, or do you have to re-up it?
I think I am assuming the purchase would last for the lifetime. And the assumption is that you are now buying sort of a permanent management scheme. And you're buying it in this particular case, it's a state-owned forest. There's national forests. How that would actually play out in a private forestry situation would be potentially more complicated.
Debora Leff from Portland Parks and Recreation. And Lisa, I was wondering if you could comment on, with any of these selling carbon credits, and how much our carbon sequestration increase in Pac Forest or in our whole system of national public lands going to mitigate for the coming changes in climate change that we see?
My back of the envelope way of calculating this is that at current rates of growth, increase in growth of use of fossil fuels, that we're not on a trajectory where these kinds of carbon markets are going to be able to address it. If I have any, if there is any potential for some self-correcting of our behaviors with respect to fossil fuels as prices continue to go up, maybe we can get into a place, a couple decades from now, then where this could actually work. The other thing that's interesting is
the magnitudes. You're talking about lots of changes already happening, changes coming. Is this token? Does it do anything?
Can I depend upon my faculty member that actually?
So the mechanisms that exist now, the primary one's called the Clean Development Mechanism, which exists under the United Nations. And it covers fossil fuel use. It covers also projected fossil fuel use. So there's a lot of work that's done. Billions and billions of credits are generated from projecting a need for energy that actually isn't being used. So in some ways, there actually is an increase in emissions that can be associated with carbon credits because you're projecting a future use. But the goal of it is to project out to be below business as usual over a period of time. But there's two big problems with the way the carbon markets work right now. One is it doesn't include forests, so all of this is excluded, and it's primarily because of this timescale issue. Because you've heard of projects where you plant trees to get carbon credits, and that's kind of nonsense because it only works if the tree is never cut down 100 years from now. or at least is never burned. And the other big problem is that it excludes the United States because we don't participate. So because it excludes the United States, China and India are going to stop participating at the end of next year. So on a political level, we don't have a mechanism that is going to be sustainable. But in answer to your original question, is this just token, or perhaps what you're alluding to, is this just token or can it make a difference? The projections are pretty well agreed upon that if the United States participated and China participated, it actually does address the value of the credits is high enough that it does incentivize reduced fossil fuel use and better technology use. The only way it works is if credits are so expensive that it's cheaper to change your behavior.
And I meant in particular the carbon sequestration addition by changing your management in public lands as opposed to the whole
Right.
gamut.
So that's what RED is. It's called reforestation. What does RED stand for? From reduced emissions from degradation of, degradation, deforestation. It's a mechanism that's parallel to CDM, but there's not a single registered project under it. And the reason is that if you actually correlate protecting forests to carbon sequestration, the value of the credits goes off the scale. And you're talking about trillions of dollars, which is far more expensive than just paying countries to not cut down their trees. So pay Brazil to just not cut down the tree and enforce that by law under contract, rather than trying to make it so complex where you're granularly addressing it in terms of carbon sequestration. So that's been one of the big challenges. Sorry.
Oh, no.
Thanks, Evan. Maybe one last question.
Hi, my name is John, and I'm just a Portlander. I'm wondering, you talked a lot about science, public lands, and a little bit about the public. What do you see the role of university researchers and scientists in terms of influencing and framing the debate around governance of public lands and making sure that the public is there to support the type of use that's going to ultimately help us adapt and manage and the coming inevitable climate change that's already occurring, as you described?
Okay, so as a natural scientist, I'm now speaking less in my own area of expertise, but more speaking, I'm now a dean, so I've got lots of different kinds of scholars that I work with on a day-to-day basis. I also realize I have to stand a little farther from that mic. In looking at what policy scholars and social scientists have been very effective in doing around public management in the last couple of decades, is there is a role for discovery-based research that has done things like taken dogma, like, if I say the tragedy of the commons, people will probably sort of nod their head, and there's this sort of notion that any common pool resource, any resource that we share as a community, will get degraded because we just can't resist that selfish influence to get more than our share of that common pool resources. Well, 2 years ago, Elinor Ostrom won the Nobel Prize in economics for, as a scholar, turning that concept on its head and saying sometimes there is a tragedy of the commons, but there's very special circumstances, or there's specific circumstances that are not uncommon where tragedies of commons don't occur, and how do we learn from that? So there's a kind of a role for university scholars to take on conceptual issues that can overturn our fundamental way of seeing the world. Now, there's other roles that university faculty play as well. And one of the things that there often happens is there is I think of it as a convening function, that in the role of bringing science and policy scholarship to the table, that we often see university sponsorship of events where multiple viewpoints are brought together, often with the notion that the university provides not just a room and coffee and donuts, but certain kinds of data sets, even harkening back to the days of sort of the spotted owl controversies in the Northwest, the ability to actually have scientists that had real maps of where the old growth really was and really wasn't, and to put that on the table to frame the debate about what we're going to do about it. That convening, that data underlaying convening function I see as very, very important. And then finally, I think the university through its education functions often does things, and I know Portland State does this, we do this at UW, where for all sorts of reasons that are pedagogically good, we are interested in students engaging with real problems that real economies and real people have. And so having undergraduate courses that are teams of undergraduates that take on a community-defined problem and suggest sustainable solutions to that problem is something that we're seeing both increasingly offered but increasingly demanded by the students, because they want to do that, they want that skill set when they leave the university to be able to put on their resume, and they deeply care about the application of what they're learning to real people in real places. So those are the three roles I see, and part of the joy of being down here at Portland State University is I feel like I see that kind of thing happening all over here, and you should be proud of yourselves.
Okay, thank you very much, Lisa. Let's give her a big hand.